A woman standing on a cliff is watching a motorboat through a telescope as the boat approaches the shoreline directly below her. If the telescope is 250 feet above the water level, and if the boat is approaching at 20 feet per second, at what rate is the angle of the telescope changing when the boat is 250 feet from shore? So, start off with our very realistic diagram. Our lady up here, our y value is 250 feet, which is constant. Our x value is changing, and theta is going to be changing as well. So, alright, so we go on to, alright, so number 2, we go on to our general equation. You've got, since we're looking for theta, we want to use tangent. We've got tangent is opposite over adjacent, so it's going to be x over 250. This 250 is constant. So when we solve for theta, it's going to be inverse tangent of x over 250. But theta is a function of time, and x is also a function of time. So number 3, we use our given information, write it all down. We got x at the point what we're looking for is 250 feet. Y is constant at 250 feet, and dx dt is negative 20 feet per second because we are approaching the shoreline and x is becoming smaller. What we want is d theta dt as the angle of elevation changes of the telescope. All right? So, implicit differentiation of our formula, you got d theta dt equals 1 over 1 plus x over 250 over the argument squared. You get chain rule, multiply that by 1 over 250, which is the derivative of our argument, times d theta, or dx dt. And solve that, kind of simplify it a bit. You got d theta over dt, or d theta dt is 1 over 250 multiplied by 1 plus x over 250 squared times dx dt. So when we plug in, step number 5, we plug in our known information, plug in the 250 for x. That will make that 250 over 250 underneath the rational expression. That'll make it 1. Very simple. You're going to have negative 20 on the top. 250 times 2 is going to be 500 on the bottom. So when you reduce that, it's going to be negative 1 over 2, or negative 1 over 25 radians per second, or it's negative 0.04 radians per second. So the answer to the question is the angle of elevation of the telescope is reducing at a rate of 0.04 radians per second, or 1 over 25 radians per second. And that is it.